Okay. All right, so this is what we're going to talk about today, this little device right here. And my name is Justin Domnitz. I have a computer engineering degree from Georgia Tech and an MBA from Georgia State. My third time speaking at 360 IDEV. It's a pleasure to be here. Most of my career I spent writing applications for the retail and food service space. So I got into the Apple Watch because I started writing an app for a fast food customer who wanted their managers to be able to watch their sales real time on their watch as they were going through their day. And we piloted that, kind of a prototype, and learned a lot of things, and now we're going into another phase with that company to try and leverage their real-time sales data right on their watch. And we're going to talk about some of the advanced things that I learned today. So I'm going to be using Xcode 9 Beta 5 and iOS 11 and watchOS 4.0. I think Beta 6 came out this week, right? While we've been here? Yeah. I haven't downloaded it yet because everything I did was for Beta 5, and Beta 4 had a lot of issues. I'm going to talk about that. So I don't know how stable Beta 6 is. Hopefully it's better. Anybody in here built an Apple Watch app before? Man, you guys are experts, man. It's gonna be, all week long, especially with all the Apple Watch material that's been going on this week, I've been thinking, I gotta show these guys something new, so hopefully I do today. But shout out and give me your feedback on any of the stuff we go over. I'm gonna talk real quick about debugging, and then we're gonna spend a good chunk of time talking about doing network requests directly from the Apple Watch. So sometime after watchOS 2.0 was introduced, you could start making network requests directly from the watch, and they really are building on that with a lot of the background functionality that we're going to look at today in watchOS 3 and then 4.0, the latest iteration. So the watch really can act independently as a device, and I think you guys might have seen some of the same rumors I have. There's a rumor that there's going to be a version of the watch that actually has its own LTE connection coming out. Yeah. So I know that some of the Android watches already have that, and it's kludgy, and you have two phone numbers. So maybe Apple's figured that out with the networking companies, and we'll see that coming. So that's what we're going to talk about today. Is the watch is independent. It's got its own network connectivity, and how do you leverage that, and what are some of the applications for that? We're going to talk about that in the context of background tasks. I'll spend a little time on user interface elements, and then maybe we get into this, maybe we're not, since this isn't a great advanced group, but there's some basic iPhone watch communication and some complication stuff we can look at too. If we don't get into that, all the code that I had in my presentation from 2015, I've updated it for the current release, and I've already posted it in Slack for everybody. So you'll see two repositories, one for 2015 and one for 2017. So both apps are available to you for free to look at all the sample code that we're going to talk about today. Okay, so just a quick note about debugging. You guys are pros, so you already know how challenging it is to debug in the simulator. It's even more of a challenge with a physical device. You just kind of have to reboot the simulator, reboot your Mac, and just kind of try and get things all working together. It seems to be better, but as I mentioned, in Xcode 9 Beta 4, I lost network connectivity to the iOS watch, or the watch simulator altogether, and I really struggled. I thought it was something I did in my app, and then in Beta 5 they fixed it. So keep in mind that there's still a lot of things going on with the simulator watch app. Okay. So network requests. So now we're to the point in watchOS 4, we're really confident we're going to start making all our network requests directly from the watch to our server. How do we know if we're online or not? Well, there is an API to know if you are still connected to the watch, to the iOS, but I haven't found a good way to know in real time whether or not I'm connected to the internet. So hopefully there will be something that comes along the pipeline for this, or maybe you can build your own. System configuration framework, which is what I rely on for reachability on the iOS, isn't available on watchOS. So that means that there's no sort of notification that, hey, you don't have connectivity to the network right now. Something to keep in mind as you go and build your network connectivity directly from the watch. Okay, so as far as security goes, the watch application has its own plist, just like your iOS application. That means it has its own it has its own app transport security configuration. It does not inherit it from the iOS application. So if you're using some HTTP server, and you shouldn't be, if you were in the networking talk yesterday, which was great, or the security talk yesterday, which was great, don't turn this off. But if you have to have an exception, or you have to turn off your app transport security for some specific web addresses, that doesn't automatically flow to your watch. You need to configure that separately there. And then, was anybody in the security talk yesterday? I forget what it was called. Yeah, good. So they talked about certificate pinning in that call in there. You're going to want to do that on your watch too. Remember, you're making direct calls to the internet from this little tiny box on your wrist, and you want to pin to certain certificates. If you're going to do it on the watch, on the phone, you need to do it on your watch too. And so the code that I'm going to give you today actually has an outline for being able to do that using OpenSSL. Anybody in here familiar with OpenSSL? A few people. It's for me, it's a pain. It's esoteric, confusing, but it does work. And so what I've done is I've built the OpenSSL library for the watch framework, and I've included it in the code that I've given you guys, and I'm going to use that to show you to do certificate pinning on the watch. So this is kind of fascinating, right? We're going to make a network request from the watch. We're going to pin it to a certificate, make sure it's secure, and over HTTPS, and we've got completely secure network connections directly from the watch, which is what you're going to want to do, especially if you've got important data you're sending back and forth. Anybody remember Heartbleed? That was an exploit that came out maybe a year ago or so. That was in OpenSSL and affected a lot of Apache and Linux machines. The code that I'm using for certificate pinning doesn't use that. Doesn't have that exploit in it. And it's been fixed, but that was a completely separate part of OpenSSL, so we don't have to worry about that. And then we talked about watch simulator connectivity issues. Okay, so let's look at some code. What we'll do. Okay, so I've got this Adv application here. I'm going to go ahead and run it on a simulator. And what I'm doing here is I'm spending time in the iOS simulator. All I'm doing is watching the watch application. That's this little application here you have on your iPhone. It's also on the simulator. And what that's going to do is that's going to give me a little indication if I'm successfully downloading my code onto the watch simulator. See how I got that little rotator right there? And bingo. Okay. So if you do have any connectivity issues while you're debugging and you're in this application, what you're going to see is you're going to see that thing just kind of stuck spinning, and it's never going to work. And you restart your simulator, reset all settings, whatever, try to get it to work. But thankfully, we got success here. So what I've got is I've got 3 interface controllers on this application, and I've got just like kind of a welcome screen here with this cool shot from Game of Thrones. I've got a Twitter interface, and what I'm doing here is I'm going and I'm downloading tweets from the internet that are going to be a certain hashtag that I've coded in there. So hold on, let's see if they come down. Yep, great. So if you do tweet and use the 360 IDF hashtag while you're in here, you might make it into the presentation. And then I've got another interface controller we're going to look at in a minute. So let's look at the code here. Okay, so I've built a little network utilities class, and I'm sharing this between the watch extension as well as my iOS application. Now I'm not using any communication with the iOS application to do any network or any data transmission, because it's all being run from the watch. The iOS application here is just a placeholder. It is not doing any sort of work for me. All of this is going directly from the watch out to the internet. So this network utilities class has, in case I used it in iOS, I've kind of if-def this out. This is the is network available reachability I talked about earlier. And then I've got 2 types of send requests here that I've built. One is a send request that's asynchronous, that's going to come back with the data. Probably you have something similar to this in your iOS application. And then I have one that is sending the background request using the background type of URL session configuration. So one's ephemeral, it's going to come back right away with the data, and the other one is a background, it's going to actually do in the background. And then down here, let's see my class. My class is both a URL session delegate and a URL session data delegate. So all this is happening on the watch again. I'm going to do my public key pinning or my certificate pinning here inside, let's see where it is. Inside my did receive challenge. So I won't go into certificate pinning in detail here, but basically I'm going to check and see if my certificate is matching what I expect. My public certificate is matching what I expect here. And then I'm going to respond to the asynchronous background data coming back from the server here. So the purpose of all this is to show you guys that everything that you might have done built for a networking interface in your iOS application, you might need to trim it down a little bit, you might need to change it just a little bit depending on what classes you're using, or if you're integrating it into an interface controller or into a UIQ controller, which you shouldn't have done, maybe you did. You need to pull that out into a model, you pull it out into its own utilities class, and then you can use it in both places. So all this code is now running on the Apple Watch, and this is how I'm connecting to the network to download the tweets. So what's really neat about this is if we go over to our Twitter interface, then we've got request Twitter search results. So what I'm doing here is I'm building up the OAuth2 request to actually get the token, and then I'm passing the token on, and again, all through the Apple Watch. So I wanted to give you all guys all this code and then show you this, because all this cool stuff that you've done to make authenticated secure network requests on the iOS application, now you're doing directly on the watch. So I'll pause there for questions or thoughts, or you guys have all built applications before, so any feedback? Let's see what else was on the next on the agenda. Oh yeah, just a quick difference between my application and the Twitter application that's available from Twitter. I'm using an app ID here to pull down the data, so this is completely independent of the user that's actually signed into Twitter on the iOS device. So we all have our own Twitter accounts that are embedded into the settings, and the application knows who we are, we can tweet from anywhere. But I'm using a 360 iDev actually account. That's app ID, and then I'm able to make requests without knowing anything about who signed in to the Twitter accounts. Because again, this is completely independent of the iOS application. Okay, so let's talk about the background refresh tasks and then the snapshot. So what we have now in, it was introduced in watchOS 3, but then it was improved in watchOS 4, is if you look in your extension delegate, which for anybody in here who's just really drinking from the fire hose and just trying to absorb watchOS stuff for the first time this conference, the extension delegate is your app delegate that you're familiar with, kind of the same concept from the iOS side. It's kind of where your application's startup and core infrastructure might get initialized. So we've got this big chunk of code that's, a lot of this is boilerplate directly from watchOS. And what this does is, I'll zoom in a little bit. That's a little easier to read. Okay, so what this does is this allows the watch to respond to regular background notifications. So your application is going to be running, perhaps if you've got a bunch of different watch applications running on the device, just like in iOS, the operating system may push your application to the background and then wake it up if you are responding to background notifications in certain circumstances. So this is important for a couple reasons. I'm going to get into from a user's interactive perspective in the app that I've shown you today. But basically, we're going to focus on the two types of background notifications. We're going to focus on the background task notification and the snapshot refresh background task here. what I'm going to do is I'm going to set this up so that instead of having to wait for the user to actually launch the app to get the tweets, we're going to just have a background task that goes and gets the tweets for the user so they're ready when they start up. Now, this application, full transparency, doesn't have a proper model for the tweet data. It's living in the interface controller. I'll leave that for you guys to do if you want. So I just put this little note here so we can look at it for the logs. Here's whether we should refresh the Twitter data. So how does this work? How do we get the background refresh to work? Well, we have a application did finish launching function, just like you have similar in your iOS application. And I'm going to call this helper method set extension background refresh. Set extension background refresh sets up my interval for refreshing my Apple Watch's background. And what I'm going to do is I'm going to give it a preferred date. For the purposes of this demo, I've given it a preferred date of 30 seconds from now. Now, this will work great if you're testing something out in your simulator. It will not work at all if you try to put this into a production app or even on your wrist, on a physical device. What Apple's done with the background notifications or the background tasks for watchOS is very similar to iOS. If you've ever done any background processing on an iOS application, you know there's a budget your app is given to you. That budget is secret. Apple doesn't tell you what the algorithm is or how much time you get. You basically say, give me a refresh in 15 minutes from now, 30 minutes from now, 2 hours from now, and the operating system will grant that if it can at that time. Watch is exactly the same, except maybe it could be more, even more controlled, or you may get less time. So for 30 seconds is great for our little demo here, but in reality, you probably want to make this an hour or more to get a background refresh to happen on your app in the watch. So what we'll do is once we've got the preferred date, I'm going to schedule that background refresh. When that refresh occurs, it's going to hit this background task right here in our extension delegate. And I put this little note here saying, hey, let's refresh our Twitter data, and then I'm going to call, this is important, I need to call set extension background refresh again. That means that every time that I set what my next background refresh is going to be, and it runs, I need to tell the operating system that I want another one. If you don't do this, it'll run one time and never again. Now, this also is novel because I can set it to a different time depending on what my situation is. Let's take my example of getting sales data for a store manager in a fast food chain again. Let's say that we want background refresh to run every hour so that they get their sales data every hour on their watch. But then we know when the closing times for the stores are. Well, it doesn't make sense to go refreshing the data if the stores closed. So I might build into this that after closing time, I don't bother refreshing the watch anymore. And that will actually make me a good citizen in the operating system's eyes because I'm not asking for a refresh when I don't need it. So we need to be thinking about that. But what's critical here is we do set up the next refresh time here when we get a refresh interval. So let's see how that all works. I've already got this set up, so let's go to my application, and I'm going to background it. Okay. And in my logs here, in the next 30 seconds, hopefully, I'll get a little note saying that we tried to do a refresh, and we should see this log message pop up. And while we wait to see that actually happens, does anybody have any questions so far?
I was just wondering, is the debugging any different when you're trying to do these things on a physical device and you're setting like the background in an hour and then you gotta just make sure it happens?
Yeah, it is. Yeah, because when I've done it on a physical device, I can get about 15 minutes to work. Okay. Which is kind of it's you want to do that last, right? But you got to do it. So you're sitting there. And what I've also done to help is I have what I'll do is I'll pair the iOS application with my watch application, and I'll send a communication when the background happens from the watch application to the iOS application, and have the iPhone application do a local notification. So it sounds a little confusing, but basically, the watch will refresh. It'll tell my phone to refresh, and my phone will pop up a notification saying, "Hey, everything happened correctly." Right. And then also test the communication between the two devices. Okay. Okay, so I am getting this weird sort of like gobbledygook here. I think it may be a beta error, I don't know. But let's see, we should have gotten our message. Yep, we did. So this is where we would have, if I had a proper model in my little demo application, I would refresh the Twitter data and be ready for the user to have that when they launch the application. Do you guys have a question? It's cool if you guys talk. I'm not picking on you. I'm just, if you guys have a question,
we were just wondering, so the background refresh, you can trigger that with the simulator, but then on the physical device, there's that like minimum amount of time that lets you have the background resets and stuff.
Yeah, that's a similar question. So the best I've been able to do on a physical device is 15 minutes. And even then, you're sitting there like you got the timer running on your back. 15 minutes is not on, and then 18 minutes. Yeah, because it's just this is good and bad because you hear all these stories of, about Android, the battery's drain all the time, the daemons are running all the time. It's a wild west out there, and Apple solved that problem because what they said is we're not going to tell you when you're going to use background refresh. We're going to do it when we're demo ready for it to happen, and that's good because the watch and the phone, the batteries last, and it's a good user experience. But for us developers, it's frustrating. It's like, wow, I want it to happen every 5 minutes. Well, you can't do that. 15 minutes into an hour is your best. So this is working. So this is great. We're refreshing the watch every 30 seconds. But we would never do this in real life. It would be more like 15 minutes. So let's take a look now at maybe a more practical use for this. Or another way to deal with the background tasks, and that's this snapshot that we've got here. So what is a snapshot? So snapshot is going to be happening at specific intervals, like if your application gets backgrounded, or if you are set up to actually regularly do a background refresh. And what we're going to do is we're going to use that to set up the application to be a little bit more user friendly for our user. So let's go back over to our application. Oops, let's launch it again. Okay, so we've got 3 screens here. We've got kind of a welcome screen that does it. It's just for the demo. We've got our Twitter feed, and I've added in a White Walker radar here. Okay, so if you're not familiar with Game of Thrones, then it's basically the zombies and yeah. What's that? It's basically the zombies in the kind of fictional Game of Thrones world that want to just kill everything. So what's that?
It was Walking Dead.
Yeah, Walking. I mean, it's the same concept, right? Yeah. So let's say I've got a radar. I want to know what the White Walkers are around. I want to avoid them. Well, when I lift up my wrist to look at my Apple Watch that's got the White Walker radar on it, then I want that to be the screen that it shows. So the way that we can do that is with Snapshot. So what we've got here is I've got this helper method, process snapshot, and what I'm going to do is when the user backgrounds the app, or when we get that background notification, I'm gonna send a notification out using the notification center, and I'm gonna send it out. White Walker interface controller become current. Now let's look at my White Walker interface controller, and inside here I'm watching for that event, and I'm calling this simple method become current. What this is going to do is, if you call this on any interface controller watch device, it's going to make that interface controller become the current one. And so now that I've commented in this notification, let's see what happens. Okay, so we'll run the application. Hopefully it runs okay. Go. Come on, install. Big money, big money. Here we go. How are we doing on time? Okay, so the launch app, the application launched, and I've got my little welcome screen again. I've got my tweets here, and let's say I background it. I'm walking around. And I'm like, okay, well, maybe there's a white walker in the area. Let me lift up my screen and launch the app. And when I do that, immediately I've got the white walker radar up on the screen. And I've done this by handling the background events and also the background refresh by telling the application that I want this to be the thing that's updated and in front when the user looks at it. So that's the purpose of the snapshot and the background task related to that. Let's further improve this. Let's turn that back off so it doesn't conflict. Okay. And let's talk about how Apple's kind of recommending that you present data to the user, especially when you're communicating with a server. In this case, where we're communicating with the Twitter server. Let me go to my Twitter interface controller. This is all the code for downloading all the tweets. What I'm going to do is I'm going to significantly improve the user experience here. I'm going to send a local notification when the tweets are ready. So here's what's going to happen in real life. So the simulator is running all the time. It lets your application stay at the front indefinitely. Your user's experience on the watch is going to be much different. So what they're going to do is they're going to launch your application, and maybe they see the rotator that's saying something's downloading, and then they're going to do this. And now the watch is going to go, the screen's going to go dark, and now they're thinking about something else. Well, what we're going to do is we're going to download those tweets in the background, and then we're going to send a local notification to the user so that they know that they can look at their wrist and they're ready. And we're going to simulate this with the simulator. So I'm just going to start hatching the dragons. I'm going to go to the home screen. So I'm going to simulate that the user has now lowered their wrist and they're not looking at the screen anymore. Okay? So when the tweets finish downloading, if everything works correctly, I should get a local notification here saying that they're ready. Your Highness, your tweets are ready. Great. So now I can dismiss that if I'm not interested anymore, or I can tap on it, and they should have been there, but you guys get the idea. For some reason they're downloading. But this is what you want to do with the application. This is actually what's recommended in. Now we're really. Let's stop that. If you watch the WWDC videos, and there's links to them in my presentation that I posted on Slack, this is the approach that Apple is recommending for the user experience. They want you to actually start your app up, tell the user that something is happening in the background. If you've got to go and communicate with the server like I do and download all these profile images, then let the user know that it's ready so they can lift their wrist up and look at it. And what I've done here with the activity indicator, I've actually built my own because there's not one built into the interface builder for a watch. And so, and that's probably because Apple's wanting to discourage that. So this sort of design pattern where we're downloading things in the background and alerting the user that they're ready on the watch is what they're recommending, probably better. Okay. And the next thing I'm going to do is I'm going to talk a little bit about the table that I built there, because it's a whole different set of code than you're used to with UI table view controller. I'm going to talk about how I built the animation to do the activity. But are there any questions about network connectivity, the infrastructure that I've shown you, backgrounding, local notifications, anything like that? Yeah.
Pretty good way to have that data connect to be ready for the application.
That's the idea behind the background refresh. So in order for that to work, they have to launch the application one time. After that, if you set up the background interval, then what you can do is you can have the data ready within your background interval. So if we're talking about, let's say, sports scores, you're kind of going to have to do what I did here, where you're going to have to go get the sports scores and then tell the user it's ready with the notification. If we're talking about maybe weather, 15 minutes is good enough, an hour is good enough. If we're talking about, I mean, you can come up with your own examples, but depending on the data, you can do exactly what you're saying with the background apps. Just get the data in the background and it's ready. And what you guys saw here with my demo application with that whole